Okay, here's a walkthrough of the second packet of notes that I gave you. Chapter 6 start off with algebraic expressions. It asks us to evaluate when x is equal to 6. They give us the expression 7 plus 5 times the quantity of x minus 4 cubed. So we take 6, plug it in for x, then perform order of operations. Parentheses, 6 minus 4 is what we would do first. That'll give us 2. Then your exponents, 2 cubed is 2 times 2 times 2, which would be 8. Then we have 7 plus 5 times 8. You do the 5 times 8 first, which is 40. And then finally, 7 plus 40 will give you 47. Here, it wants to evaluate when x is equal to 4, y is equal to negative 2. We have negative 2x squared plus 5xy minus y cubed. Plug in 4 for x, y for negative 2 for y. So that'll be 4 squared, which is 16. And then here, negative 2 cubed, which is negative 8. Negative 2 times negative 2 times negative 2, which would be negative 8. Then we can multiply each cluster. We have 2 times 16, negative 2 times 16, which is negative 32. 5 times 4 times negative 2, which is negative 40. Then a negative to a negative in front of this 8 turns it to positive. So negative 32, negative 40 would be negative 72. Negative 72 plus 8 would be negative 64. If you have any questions about operations with signs, shoot me an email. I can give you a link to one of my other videos. Also, as far as order of operations, I can give you the link to that as well. Here, like terms and unlike terms. 5x and 3x are considered like terms. These are terms that you can add and subtract from each other with no problems. They have to have the same variables, same exponent on your variables, same amount of variables. So 10x squared, negative 11x squared are like terms. See here, we have x squared y and x squared y in both terms, so they're like. And even not having any variables at all, regular numbers that we're used to dealing with are considered like terms. Here we have unlike terms. If anything changes with your variables, whether it be the actual variable itself or exponents on your variables, they are not like terms. So 5x and 3 are not considered like terms. 10x squared, negative 11x are not like terms. One has the power of 2, the other one doesn't. And then here x squared y and just xy are not like terms. Here we have just a variation of similar situations where we would add and when we would not add. 5x and 3x like terms, that'll give us 8x. 5x plus 3 is already in lowest terms. 5x plus 3y already in lowest terms. 5x squared plus 3x squared, that will give us 8x squared. And then here 5x squared plus 3x, one has a power of 2, the other one doesn't, so that's already in lowest terms. You cannot add them together. So if I had the expression 4x plus 3y plus 6x minus 8y, and I wanted to simplify or combine like terms, I would do 4x plus 6x, which would be 10x. 3y minus 8y would give me a negative 5y, so it's 10x minus 5y. If I have the expression 5 times the quantity of 3x minus 7 minus 6x, distribute the 5. 5 times 3x is 15x. 5 times negative 7 is negative 35. Now combine your like terms. 15x minus 6x is 9x. So it'll be 9x minus 35. Or you can write that as negative 35 plus 9x. Just remember that whatever's positive needs to stay positive, whatever's negative needs to stay negative. So if you rearrange the terms, just make sure the 35 stays negative, 9x stays positive. Here we have the quantity of 6 times, well, the expression of 6 times the quantity of 2x squared plus 4x plus 10 times the quantity of 4x squared plus 3x. Distribute the 6, distribute the 10. That gives us 12x squared plus 24x plus 40x squared plus 30x. Combine your like terms. 12x squared, 40x squared is 52x squared. 24x and 30x is 54x. In this next one, 8x plus 2 times this quantity of 5 minus the quantity of x minus 3. So we have grouping symbols embedded inside of another set of grouping symbols. You always work your way inside out. First, do your innermost grouping symbol and work your way out. So we're going to distribute this negative. The negative is what's right up against the parentheses, not the 5. So we distribute the negative. So that would be 5 minus x plus 3, because negative to a negative turns positive. And then I can remove the parentheses. Now inside of my brackets, I can combine my 5 and 3. So that'll be 8 So that's 8 minus x inside of the bracket. Now I can distribute that too. 2 times 8 is 16. 2 times negative x is negative 2x. Now combine your like terms with the 8x and the negative 2x, which would be 6x. So that'll be a final answer of 6x plus 16. So make sure you're comfortable with combining your like terms before you move into 6.2, because 6.2 leans on that capability. So here we have linear equations. This section actually presents linear equations as if you already know them. So make sure you're comfortable with that. If not, shoot me an email. I have another video that talks about linear equations, so we can, and I can give you more examples of that as well. So make sure you stay in contact. So linear equations, 2x plus 7 equal to 5 is an example of a linear equation. And solutions that we're looking for are just going to be values that will make that statement true or make that equation true. So we want to know, when is 2x plus 7 equal to 5? That's when x is equal to negative 1. When I plug negative 1 in here, 2 times negative 1 is negative 2. Negative 2 plus 7 will give me 5. So what statement will make this statement true? What value will make the statement true? That would be negative 1. So the way we'll solve by using what I call opposite operations. Addition and subtraction are opposite operations. Multiplication and division are opposite operations. So your goal is to get that variable by itself on one side of the equation. So if I have x plus 5 equal to 8, we subtract 5 from both sides to cancel out the addition of 5. Once we do that, that will give us x equal to 3. Remember, the sides of your equation will be split up by your equal sign. Left side of the equal sign, right side of the equal sign. So if I have y minus 10 equal to 30, I want to solve for y. Add 10 to both sides. That will give me y equal to 40. The 10 cancels out on the left side. 3 plus 10 is equal to 40 on the right. 5a equal to 13. 5a is the same thing as 5 times a. That implies multiplication. So in order to remove the multiplication of 5, I need to divide 5 on both sides. Divide 5 on both sides, that will be a equal to 13 over 5. So you don't have to simplify that any further, because the 5 doesn't go into 5. 5 doesn't go into 13 evenly. If it did, you would be expected to simplify. But 13 over 5 is good enough. Now, if I had something like 4 over 6, you are expected to reduce that down to 2/3. Your program will expect the most simplest way of expressing your answer possible. So make sure you reduce your answers when you submit your final submissions. So last one, y over 9 is equal to 11. Multiply both sides by 9 because that's division. Multiplication cancel out your division. So 9's cancel on the left. 11 times 9, we have 99 on the right. Y is equal to 99. So we have more than one operation. 2x plus 3 equals 17. What I would do first is subtract 3 from both sides. 3's cancel, leave me with 2x equals 14. Now that we're at 2x equal to 14, that's when we would go ahead and divide. That's why I boxed that in. Once you have your single term, that's when you're looking to go ahead and divide when we're talking about these type of problems. Divide both sides by 2, x is equal to 7. Once again, applying the opposite operation thought process. 2 times x, so that's why we divided by 2. Here we have 2 times the quantity of x minus 3 minus 17 equal to 13 minus 3 times the quantity of x plus 2. Distribute 2 times x, 2 times negative 3, that's 2x minus 6, minus 17 still there, equal to distribute not just 3, but negative 3, 13 minus 3x minus 6. Negative 3 times x times 2. Now, before you just move anything across the equal sign, I would suggest that you combine your like terms. So on my left side, I have negative 6 and negative 17, which is negative 23. On my right side, 13 minus 6, which gives me 7 right here. So next, I have 4 terms. 2x minus 23 equal to 7 minus 3x. It doesn't matter which term you move first. Just remember, as long as you stay correct with your mathematics, you'll still get the same value as far as when you're finished. So if I decide to add 23 first to both sides of my equation, it cancels out on my left, leaving me with 2x on the left. On the right, 23 plus the 7 will give me 30. Then from there, I add 3x to both sides. Your goal should be to get all of your terms with x on one side, all of your terms without x to the other side. So I took my 23 to the right. So now I should be bringing my 3x to the left. So I add 3x to both sides. So that'll be 5x equal to 30. Now We have our single x term once again. Divide by what's in front of that x. So we're dividing both sides by 5. That'll leave me with x equal to 3. If we have fractions involved, we can do what we call clearing out your fractions. The first thing you want to do is find the LCD of each denominator in the problem. So we have 2 and 5, that are denominators. The lowest common denominator from out of the 2 and 5 would be 10. That's the smallest number that both of them can divide into evenly. 2 and 5 can divide into 10 evenly. That's the smallest number that they can divide into. Now, let's say if you didn't see 10, let's say you saw 20, it wouldn't be the worst thing in the world if you decide to use 20. It's just that your numbers would be small or would be larger, and you would most definitely have to reduce at the end. It's not a problem as long as the 2 and the 5 can divide into whatever you're calling your LCD evenly. You still get the same answer when you're finished. So once you find the LCD, you multiply each numerator by the LCD. Notice I didn't do numerator and denominator. I want to multiply each numerator by the LCD. From there, you simplify. What that means is the 2 can divide into the 10, which will leave me with 5. 5 can divide into the 10 and leave me with 2. 5 times 3 is 15x. 2 times 8 is 16x. So that's what we mean by simplifying. Of course, back here, 10 times 4 is 40. Also, don't forget that 10 needs to be multiplied to each term. So even if that term doesn't have a denominator, it still needs to be multiplied by each term in order to not change the equivalency of the problem. So after that, once you want to get all the terms with x on one side, so we subtract 16x to the other side, cancel out on the right, leave me with negative 1x equal to negative 40. Then take that negative to the other side or divide both sides by negative 1, and you'll be left with x equal to positive 40. All right, so let's try it again. We have x minus 3 over 5 minus 1 equal to x minus 5 over 4. LCD is 20, so I'll multiply each term, even the 1, by 20. 5 goes into 20, leaving me with 4. 20 times 1 is 20. 4 goes into 20, leaves me with 5. So now distribute those terms or those numbers sitting in front of your quantities. 4 times x is 4x. 4 times 3 is negative 12. And negative 20 is still there. 5 times x is 5x. 5 times 5 is 25. Combine my like terms, negative 12 and negative 20 is negative 32. Add the 32 to both sides. That'll just be 4x on the left. 5x plus 7 on the right. Subtract 5x from both sides. That'll be negative x equal to 7. Take my negative over. X is equal to negative 7. Here we have a simple example of a linear equation, but something different happens. We have 2x plus 6 equal to 2 times the quantity of x plus 4. If I were to distribute, that would be 2x plus 8 on the right. Subtract 6 from both sides. Then subtract 2x from both sides. That leaves me with 0 equal to 2. Notice if 2x cancels on the right, then it has to cancel on the left as well if you have 2x minus 2x. So don't be afraid to cancel out your variables completely. So notice what happens. Your variables cancel. You were left with a false statement. Your answer is not false statement. That's just what happens. You were left with a false statement, and your answer is no solution. So whenever your variables cancel out completely and you have a false statement left, your answer is no solution. All right, here, 4x equal to 6, or 4x plus 6 equal to 6 times x plus 1 minus 2x. Distribute the 6, that'll be 6x plus 6 minus 2x. Add your like terms, 6x minus 2x is 4x. So that's 4x plus 6 equal to 4x plus 6. Subtract your 4x's from both sides. Once again, my variable is going to cancel, and I'm left with 6 equals 6, which is true. Or you could have had 0 equals 0. It depends on what you decided to do with your problem or with your operations. So 6 equals 6 is a true statement. When your variables cancel and you have a true statement left, that will be all real numbers. So when your variables cancel and you have a false statement, it's no solution, no value. There's no value you can plug in for x that will make that a true statement. When your variables cancel and you have a true statement, it's all real numbers. Anything you plug in for x will make this true. Anything you plug in for x will be a solution. All right, so that's the first part of that packet. Let me know if you have any questions.